A vector is a mathematical quantity represented by an arrow with both direction and magnitude. Oh yeah! And that's no joke. If you can memorize that, then you have a solid foundation of vectors. If stage 1 is knowing what a vector is, stage 2 is performing elementary operations with them, such as splitting integer vectors into its x and y components, adding two vectors to make another vector, subtracting two vectors, scalar multiplication, vector negation, and vector normalization. If you know trigonometry, then you're at stage 3. You can actually use direction and magnitude alongside the xy representation. You can use the sine and cosine functions to convert from the polar coordinates to Cartesian coordinates. And you can use the Pythagorean theorem and tangent to go from the Cartesian coordinates to polar coordinates. You also memorize trigonometric tricks, such as all students take calculus, the 45-45-90 triangle, and the 30-60-90 triangle, which is as easy as 1, 2, square root of 3. And if you're in stage 4, you know that complex numbers can be represented by a vector in the complex plane. If multiplying by -1 flips the vector 180 degrees, multiplying by I rotates it by 90 degrees. To be a stage 5 vector enthusiast, you need to know how to multiply two vectors by finding its dot or cross product. If you're a physics student, then you've actually already come across these. You have used dot product calculations to find the torque and normal force, and you've used the cross product calculation in Lorenz's equation. Looking at torque, if a force is applied parallel to a handle, it has no effect. But if you push perpendicularly, then you can just use the torque formula. What if you push at an angle? Well, the force would have to be broken down into the perpendicular and parallel components, and that's exactly what the dot product formula does. The cross product is similar, in that the magnitude is determined by the angle between them, but it's different in that the resulting vector is perpendicular to both of the crossing vectors. So somebody in stage 3 would associate cosine as x and sine as y, but somebody in stage 5 can have an alternate viewpoint based on the parallelness and perpendicularity. Data analysis with vectors goes crazy. Wind at any point on the Earth blows in a certain direction with a certain magnitude. So meteorologists and aerodynamicists use vector fields to show the direction and magnitude for a given area. Other fields, especially force fields, like gravitational fields, electric fields, and magnetic fields, they abstract vector fields with field lines to show the direction, and equipotential lines to show the magnitude. In stage 7, you have tensors. I know nothing about tensors, but it looks like a multi-dimensional vector, itself made out of vectors. I am too poor to buy bot subs. More videos coming soon to theaters near you.